We're still solving by factoring, and then later on, I can't remember if it's 22 or 23, I think it's indicator 23, that we actually do a different method of solving these. So we'll still get the same answers, but just another way to go about it. Whenever you are solving a quadratic equation, the word quadratic is just a term describing anything that has a power of 2. So like in these problems that you guys see on the board, we see v squareds, x squareds, p squareds, k squareds. It can be any variable, but the highest power of a quadratic equation is 2. And that tells us we have the potential to have 2 solutions. The solutions are a value or values. Sometimes most of the time there's 2, but there are some cases where you only have 1 solution. And whenever we start getting into the graphing portion in indicators 25 and 26, you'll see how those solutions look on a graph. But I want to let you know that the solutions of a quadratic equation can be called a lot of different things. So you can solve by factoring. You can solve by the quadratic formula, which we will be doing later. And you can also solve by graphing. Just like we did with straight lines, you can do these also with powers of 2. So sometimes the other words tend to, you see them more when you're graphing, but I do want you guys to know that those words all go hand in hand. If you ever are told to find the zeros, that just means find the solution. If you're ever told to find the roots, you're just finding the solutions. And the same thing, x-intercepts are also just solutions. And again, those terms tend to go more with graphs, but if you are told to find one of those, you are simply just solving the equation. That's all you're doing. So we're going to get started with the first example, and if you can see, it's already factored. The first factor is 5v plus 2, and the second one is v plus 8. So we are trying to find the value of each factor that would make it 0. So we actually have 2 possibilities. The value of v that would make this term 0, the value of v that would make the second term 0. So we can set those equal to 0 and solve. All right, so for this first factor, just like we did yesterday, we're going to find out what makes this 0. So if you want to solve that equation, we would subtract the 2 over first to get v by itself, which is -2. Now in this case, we have to divide by 5 to get v by itself. Yesterday we didn't have anything to divide by, but today we might on some problems. Not all of them, but some. So we have a fraction as one of our solutions. That's totally fine. It happens all the time. You're going to say, I do want you to know I don't want decimals. Just leave them as a fraction. Now, and then the second term, and if you guys are to the point where you can solve this one mentally, I'm okay with that. You say, you guys tell me what plus 8 gives me 0. -8. There we go. So we have 2 solutions. One is a -8 and one is a -2/5. Because as long as one of them is 0, it could be one or the other that would make those, when you multiply them together, to be 0. All right, so the only thing that we're going to do a little bit different today is there will be some coefficients when we factor. So I do want to make sure that we go through some of these. All right, so let's focus on the middle of the board for just a second. All right, that first example, 4v squared minus 16v plus 7. All right, so this would correspond with your indicator 20, day 2. And so on this assignment, we would always, this 4 gets multiplied to the 7. So I want to find out what multiplies to 28, but adds to -16. So we want to find out the 2 factors that multiply to 28, but they add the negative 16. And if you guys do not know those factors right off the bat, make a list. Let's see if this orange stands out. So I do want to let you guys know there's lots of ways to multiply to 28. There's 1 times 28, 2 times 14, 4 times 7. Out of those 3 factor pairs, which one could we make a negative 16 with? All right, the 2 and the 14. So 2 times 14 is 28. 2 plus 14 is positive 16. How can we make these add to a negative 16 but still multiply to a positive 28? Yep, make them both negative. So these are the 2 numbers that we're going to use to split up that middle term. So I'm going to bring this down 4b squared, but instead of writing minus 16b, I'm going to use a negative 2b and a negative 14b. And then we do the grouping like we did yesterday. So that first group, we got 4b squared and 2b. What do they have in common? A 2b. And if I divide both of these by 2, take out a b in each term, what am I going to have? 2b times what gives me 4b squared? 2b. And 2b times what gives me negative 2b?
Negative 1.
Negative 1. All right, and then on the second term, always remember if this, whenever you do your second group, if that starts with a negative, always take a negative out. So that way your parentheses match. You say, what do 14b and 7 have in common?
Negative 7.
A negative 7. And if I take out a negative 7, I would need a positive here, 2b, to make 14b. And then a negative times a negative gives me the positive 7. All right, are there any questions on that step? Getting those groups and finding out what they have in common? And then, since we see that those match, we do know that one of our factors is 2b minus 1. Then the remaining parts, the greatest common factors we took out, makes the second factor, 2b minus 7. So now, just like we did yesterday, we are going to set those equal to 0 and find the 2 values that make it work. When you have coefficients, you're more than likely going to have a fraction. So for this first factor, 2b minus 1, if I set that equal to 0, am I going to add 1 or subtract 1 here to get b by itself? All right, we're going to add our 1. Now, I divide by 2. All right, I actually saw this. There was a question on one of your quizzes. Is 1 over 2, is that 1/2 or is that 2?
1/2.
It's 1/2. I don't know how many people I saw tell me that they actually was 2/4. Saw a lot of people tell me 2/4 was 2. But on this one, 1 divided by 2 is a fraction. So we have a solution of 1/2. And then for the second factor, 2b minus 7, we make that equal to 0 as well. Solve it the same way, add the 7 over. Now can I take 7 divided by 2 without using decimal? No, so we just leave that as a fraction as well. So if your factors do have coefficients, you will have fractions in your answer. All right, what do you guys think so far? All right, now how does B and C look different? All right, C isn't set to 0. And just like we talked about yesterday, you do want your equation, one side has to be 0 before we can factor it. So if I want this to be equal to 0, how do I move that 7k to the other side? Do I add it or subtract it? All right, so we're going to subtract the 7k. Now, whenever we're factoring, we always like things to be in a certain order. Are there any other just plain k terms to combine it with? No, but where do you think I would want that minus 7k to go? Yeah. We want it to go kind of in the middle. So whenever we rewrite this, I'm going to bring my 5k squared down. Then I'm going to bring down my minus 7k, and then bring down my negative 6. That way it's just in order, so that way we can factor it appropriately. Whenever you're writing things in order from the highest exponent to the lowest exponent, that's what we call standard form. Now from this point, we would factor just like we did any other problem. So we always want to multiply to the outer numbers. 5 times negative 6, so we're multiplying to a negative 30. And we're adding to that middle term of negative 7. You guys have any idea what factors would do that? You know, say would 5 and 6 do that? 10 and 3? Okay, I like where you're going. So we've got a 10 and a 3. Now, we got to add some negatives to make this happen.
The 10's got to be negative.
All right, so if I made the 3 negative, a 10 plus a negative 3 would give you a positive 7. So if you want this to be a negative number, the bigger number will be the negative. So negative 10 times 3 is 30. Negative 10 plus 3 gives me the negative 7. All right, so the negative 10 and the positive 3 will be how I split up that negative 7k. So I'm going to write negative 10k plus 3k minus 6 equals 0. All right, let's look at this first group. What do they have in common? I wouldn't even say, look at what's first. Is that positive or negative? You know, say, if the first part of your group is positive, keep it positive. If the first number is a negative, then take out a negative. So this one, it's just a 5k. So if I remove a 5k from each term, what would be left?
K squared. I'm at K.
Just a k
Minus 2.
minus 2. All right, now, in this second group, the 3 is positive. So let's take out a positive 3. Now, if I take out a positive 3, what would be left?
K minus 2.
K minus 2. All right, our parentheses match, so we know we did that right. So we have K minus 2 is one of our factors. And our second factor comes from those 2 terms we took out. So now we have our 2 factors that we can solve. All right, so our first one doesn't have a coefficient, so it's a little bit easier to solve. What minus 2 gives me 0? Positive 2. And then for our second solution, 5k plus 3. So you got to get k by itself, so let's subtract that 3. So 0 minus 3 is a negative 3. And I can't divide that by 5 to get a whole number, so I'm going to leave it as a fraction. Negative 3/5. So on example B, we had 2 fractions. That's okay. You can have one of each. Sometimes you do get two whole numbers like we did yesterday. So the solutions can be a little bit of everything. But just remember, if you have three terms, if you have a squared term and you have a term that has a variable, just a variable by itself and a constant, you are going to factor with those factor pairs, finding out what multiplies to the first and the last and adds to the middle. All right. So whenever we have two terms, sometimes you will want to do greatest common factors, but every once in a while we do have one of those special cases that's a difference of squares. If we look at D, do 16 and 25 both have square roots? Can you take the square root of 16 and the square root of 25? Yeah, those are both perfect squares. Are you subtracting those? So we can follow that difference of squares. Now this is a shortcut. You guys can just tell me, how can I perfectly split up 16x squared?
4.
Alright, so 4 and 4 give me 16, but how do I get x squared? X times x. And how do we get 25? 5 times 5, but it's supposed to be a negative 25, so if it's a negative 25, what do I have to do with signs? If they're both negative, that'd be a positive.
So one of them positive and negative.
One of them positive, one of them negative. All right, it's factored. So now all you have to do is find the solutions of each. So for that first solution, the 4x plus 5 equals 0. So we're going to solve that. So we're going to subtract our 5. And I'm going to actually skip my work and I'm just going to change it to a negative 5. 0 minus 5 is negative 5 divided by 4. And leave it as an improper fraction. You know, say 1 and 1/4 is messy. You can leave it as negative 5/4. Now, on the other side, we got to solve 4x minus 5 equals 0. Since they have different signs, they are going to have different solutions. So, I'm not going to show my work, but I'm going to add my 5 over and make it a positive 5, and then divide by 4. So whenever it's a difference of squares, your solutions will be very similar. They'll just be opposite signs. All right, and last but not least, we have one more that's not set equal to 0. But what am I going to do to this negative 4? How can I make this equal to 0? All right, and do I have anything I can add the 4 with?
The 6.
The 6. So I'm actually going to factor 7p squared plus 37p. 6 plus 4 gives me a plus 10 equals 0. I actually want you guys to try this one on your own. So now that it's set equal to 0, you're going to factor it a lot like we did examples B and C. used to split up the 37 feet. What do we have in common there? Just a p. So if I take a p out of each term, it's just 7p plus 2. Now what about here? Just a 5. And it's a positive 5 because that starting term is positive. So if I divide each one by 5, am I also left with 7p plus 2? I'll say that's our goal. So we're going to solve 7p plus 2 and then p plus 5. Now if you set each one of those equal to 0, I'm just going to give you the solution. Tell me if you got these. For the first one, it's negative 2 over 7. And for the second term, it's negative 5. How'd you do? Good? Uh-huh. Right. Whenever you're doing those, it doesn't matter which factor pair you write first.
It just kind of swaps the parentheses on the line.
Yeah, it swaps the parentheses. So like on yours, you took out a 7p on one and you took out a 2. And then your parentheses that match were the p plus 5, right? On those, it doesn't matter which term you put first. Your groups will just look slightly different, but it will give you the same results. It'll just be in a different order. But your assignment for today is posted. And then what we will do is we will do a little quick review in class tomorrow. There won't be an assignment tomorrow, and then we're going to quiz over this on Friday. Okay. I'm going to hit pause if that's